Lesson 2.2 for trigonometry is using the tangent ratio to find a missing length. So our previous lesson is where we found the ratio and we used it to find a missing angle, and now it's doing the length. So in this case, they're saying, what could I find in this triangle? Well, I could find the other missing side because all angles, when added together, should add up to 180 degrees. Okay, so we already know that this is 33 for G. This H angle would have been 90, and then we could have done 180 minus 33 minus 90 to get our missing angle. So that's what we could do to find out that missing piece. Okay, so we have 180 minus 33 minus 90 gives us 57 degrees. Now, depending on what angle you're looking from, you could look from 33 degrees. If you're looking from 33 degrees, this would be called your hypotenuse. This would be called your adjacent because it's the other side length coming out of 33 degrees, or angle G. And your opposite would be FH. So once you have it labeled, you could use the tan ratio to find out a missing side. So we have tan 33 degrees equals our opposite side. We don't know, but we do know our adjacent is 4. So we can replace adjacent with 4. So as you can see, I can actually find my opposite side by moving that 4 to the other side. Okay. So once you have your opposite side, so I would use my calculator and I would calculate that. I would multiply by 4 because you want to get the opposite side by itself. So you're going to go 4 tan 33 in your calculator. So I'll show you how to do that. So in your calculator, clear what you have there, and you're going to put 4 multiplied by tan 33. TAN, and in brackets 33. Close your brackets. So the number is just multiplying in front of your tan. And you should get 2.59, which I would round to maybe 2.6 to the nearest tenth. So we just found out that our opposite side would be 2.6, and that would be in centimeters. Our third side, our hypotenuse, we can always find by using Pythagorean theorem, which is a squared plus b squared equals c squared. And you can pick whichever side you want for a and b as long as it's not your hypotenuse. So your a could have been 4. Your b is 2.6. And your c we'll find. So 4 squared is 16. 2.6 squared in my calculator is 6.76. And then we'll add those two sides. You always add your a squared and b squared together. So I just found that c squared equals 22.76. And then I would square root both sides to get c by itself. So don't forget to square root your answer to get your c value. So it would be 4.77 or 4.8 centimeters if you round to the nearest tenth. So we know we're doing it properly because, as you can see, 4.8 is the highest and biggest side length. So our hypotenuse should always be the largest side length. So just from knowing that information, I was able to solve for every piece of this triangle. So now they're giving us a right triangle called PQR. So we're going to start by labeling triangle PQR. It tells us that Q has to be that 90-degree angle, so make sure that your little box is labeled as Q. So that right angle is labeled with Q. They tell us that one of our side lengths is PQ. So we can choose where that P goes and where that Q goes and where the R goes. The other sides don't matter which one you kind of label. So they're telling us that P to Q is 46.1 centimeters. And angle P, which is this one right here, they're telling us is 34.5 degrees. So the trick is you always have to look from the angle given. So it's really important that you look from an angle other than 90 degrees. So we're going to look from 34.5 degrees. That's going to be our theta that we actually know. So when we label our sides, we need to label our sides as our hypotenuse. Coming out of P is our largest side. And the other side length coming out of P is called our adjacent side, which means that our opposite side is R to Q. Okay, so step one, let's write our tan ratio. So they do want us to determine the length of R to Q. So our missing side is our opposite side. So I'm going to put a little question mark there. What we can also do is just leave it as OPP when we fill it into the equation. So tan of P, which is our angle that we're going to be looking from, is always equal to our opposite side over our adjacent side. So remember TOA, opposite over adjacent. Then we'll fill in our angles and our side lengths. 34.5 replaces angle P. Our opposite side we don't know, so we're going to write OPP. And our adjacent side we're going to rewrite as 46.1. Now the trick is we have to get the OPP, the opposite side, by itself. And remember that we always do the opposite. So I did try to show that in the first example. So your goal is to isolate for OPP. So if you notice, this is dividing. So it's at the bottom of the fraction, which means it's dividing. So you need to multiply both sides by 46.1 in order to get rid of it. Okay, so we need to multiply by 46.1. And that will give us the OPP by itself. So in our calculator, we should be putting 46.1 multiplied by 1034.5 degrees. Okay, so that's what we're going to be putting in our calculator. Before we actually calculate it, always make sure that your calculator is in the right mode. So it's very important that you confirm that your calculator is in the right form. So in this case, a trick that you can do is if you remember the tan 45 trick. So if you put 10 and then put 45 in brackets, you should get that the answer is 1. So if you can try that, that would confirm that you're in the right mode. If not, you're going to have to find the DRG button and then keep switching it until you have a D letter at the top. If you guys look at the very top, do you guys see how I can actually change mine at the very top there, where there's different ones? You can either see RAD, R-A-D, which is radian mode, so that would be wrong. You can either have G mode or you can finally have D mode, which is degrees. So make sure that it's in degree mode to get the correct answers. Okay, so once you're in the right mode, that's when we're going to put that 46.1 multiplied by 10, and then the angle. Our angle has to go in that bracket, 34.5. So remember, 46.1 times 10, 34.5. Close your angle, close your bracket. So I'm just double checking, 34.5. Okay, so once you have that, so 46.1 times tan 34.5 degrees gives us 31.7 if we round to the nearest degree, or the nearest tenth. So 31.7. So that 6 after the decimal means you have to go either stay at this, keep it the same, or move up. And the 8 to the right means you move it up. So 31.7. So that's what they want us to find. They want us to find out that angle. So only when you're trying to find Oh, sorry, that's actually your side length. That should not be an angle. So in this case, it should be 31.7 and centimeters. So it's a side length. Side length. So trick is you use tan inverse when you want to find an angle. So if you're trying to find an angle, that's when you use that tan inverse button that was from yesterday's lesson, and you just use tan by itself with that with your angle or ratio to find a side length. So as you can see, no steps and no steps above did I use that that tan inverse button that I did yesterday, because in this case I'm trying to find a side length. Okay, so always ask yourself, are you trying to find a side length or an angle? If you want to find an angle, that's when you have to do that tan inverse button. Okay, so that's a little hint to you to make sure that you use the right tan button. So our answer is 31.7 to the nearest tenth, so make sure you round correctly. Tenth means one number after the decimal. So when they say direct measurement, this is actually when you take a measuring tool. So when you use a measuring tool, to find a length or angle. So we could use a clinometer to find out a missing angle, or a protractor to find a missing angle, and we could use a ruler to find a missing side length. Now, an indirect measurement is, what if you're trying to find out the distance across a river or a pond, right? And you don't have a boat and you don't have a way of getting across it. Well, we can do other kinds of measurements, and that would help us determine the actual length without actually measuring it. So finding a length or angle using calculation without measuring the actual side you need. So let's say I want to solve for the distance between one side of the river and the other side. We wouldn't actually measure it. We could measure other things around it, and then use our calculations, use this information above to find out the missing piece. So this one, example number 1, is just saying determine the length of x to y. So this is the length. So remember, whenever you're looking for a length, you shouldn't be solving for that tan inverse unless you're solving for an angle. Okay, so let's first label our x to y. So this is what we're solving for. We don't know what this side is. X to y, that's what we're trying to find. Step 1, we have an angle. We have 70 degrees. We don't want to ever solve from 90 because that does change our information. So don't use 90 for calculations. Use the angle other than 90, which is 70. So this is the angle we're looking from. Label your lengths. The longest side should always be labeled with your hypotenuse. As you can see, that's one length coming out of Z. That's the angle we're looking from. The other side length coming out of Z should be called your adjacent side. And the remaining side is your opposite side. So very similar to our previous steps. We have the angle, we have the adjacent, we're trying to solve the opposite. So same steps. Tan of angle Z, which is what we're looking from, is always equal to our opposite side over our adjacent. So in order to solve this, we have to have 2 of the 3 pieces filled in, meaning either Z or adjacent have to be filled in, or Z or opposite have to be filled in order to find out a missing side. Z is 70 degrees, fill it in. Opposite, we don't know, so we're going to just leave it as OPP. But our adjacent side, we can fill it in with just 5. You can put 5.0, but it's just 5 in the end. Now we need to isolate for our opposite side, so we have to get rid of this 5 by doing the opposite. So right now it's dividing by 5, so you need to multiply both sides by 5. Gone, gone. So in our calculators, we're going to have to do 5 multiplied by tan of 70 in brackets. The angles, anything attached to tan like that, whatever comes after will always be in brackets. And then we're going to use our calculator, 5 tan 70. Make sure you're in degree mode. 5 multiplied by tan of 70 degrees, close your brackets. Check that you guys are getting 13.7. So this is a length, 13.7. So as you can see, I used tan because I was trying to find a side length. 13.7 to the nearest tenth. And this is in centimeters. Okay, so that's my answer. Example number 2, they want us to find VX. So this is the side we're trying to look for. And then what we want to do is we want to fill in what angle we're looking from. So this is the angle we're looking from, which means that one of these 2 lengths here is our hypotenuse, and the longest is always your hypotenuse, which means that the side we're looking for is called our adjacent side. And then opposite is literally opposite to the angle you're looking from. So OPP. So in this case, we're doing tan from angle V, because that's the angle we're looking from. And we want to set it up as tan of V is equal to always opposite at the top and adjacent at the bottom of your fraction. V is equal to 42 degrees. You can always put brackets after your tan if that helps, or you can just leave it as tan 42. Our opposite side we actually know this time is 7.2. And our adjacent side we don't know, so we leave it as ADJ. ADJ. Okay, so there's a trick to this one. So there is a fast trick, but you got to remember this, okay? So if we're trying to solve for something, you'll notice that we're trying to solve for something, but it's in the denominator. We're never allowed to solve for something in our denominator. So there's a trick that what we want to do is we want to put both sides as fractions. So in this case, it was tan 45, so you're going to write it as a fraction by going over 1. So anything that's at the top of the fraction and there's nothing at the bottom can be written over 1. And the trick is that as long as you do the same thing to one side and the other side, it's still going to be mathematically correct. So what I'll do is on the right side, I want this guy to go to the top. So I'm going to flip it. So that means adjacent is going to come to the top. 7.2 is going to go to the bottom. What I do on the right, you have to do on the left. So 1 used to be at the bottom. Now it's going to go to the top of the fraction. Tan 45 is going to go to the bottom. So the reason we do that is because we cannot solve for something in our denominator. So by flipping both sides, we now have adjacent at the top. Now it becomes similar to our previous steps where we are trying to get rid of this 7.2 by doing the opposite. So the opposite of dividing by 7.2 is multiplying both sides by 7.2. So these ones will cross each other off. So in our calculator, we're going to have to do 7.2 multiplied by 1 divided by tan 45. So if we can do that exactly how we see it, we'll get what the adjacent is equal to. So adjacent is equal to we're going to do 7.2 multiplied by 1 divided by 10. And we said the angle was 42. Okay, so remember I'm doing 7.2 times by 1 divided by tan 42. And you should be getting 7.996, which rounds to 8.0 if you're rounding to the nearest tenth, or just 8. So 7.996 rounds up to 8 as a whole number. So they want it to the nearest tenth of a degree. So we do have 7.99, which rounds to like 8.0. Think of this number right here, 79. The next number after 79 is 80. So that's why we put 8.0. And that's going to be in centimeters. So the trick is, remember, if you ever have something at the bottom of your fraction that you're trying to solve for, flip both sides. And then you can just do the exact same thing as the previous step where we get rid of the 7.2 by multiplying on both sides. And then we use our calculator to write exactly what we see. So 8 centimeters is our answer for V to X. So here they're saying that at a horizontal distance of 200 meters from the base of the observation table, so when they're talking about base, we're talking about this right here. So that's going to be 200 meters. The angle between the ground and the line of sight is 8 degrees, which is already labeled. There's our angle of inclination. How high is the tower to the nearest tenth? We're trying to solve for this height. So let's label our triangle. This line of sight is your hypotenuse. The other side length coming out of 8. So remember, there's always two side lengths coming out of your angle. One is your hypotenuse. The other one is your adjacent side. And then we have our hypotenuse. Or sorry, our opposite side. The missing side, opposite side. Okay, so tan of our angle. So we'll just say theta for now. If we don't have an angle, if we don't have like a letter, I'll just use theta instead, is equal to opposite over adjacent. I'm kind of writing out the formula so that I practice it each time and I write this the proper stuff in each part. So tan of the angle, which is theta, is 8 degrees. So we already know that the angle needs to be replaced with 8 degrees. Our opposite is going to stay as OPP because we're trying to solve for that. But our adjacent, we actually know, is 200. So these ones are pretty basic because we're just trying to get OPP by itself by getting rid of the division of 20. So do you see how it's dividing by 20, which means we need to multiply both sides. Sorry, but not by 20, by 200. So it's dividing both sides by 200, so you multiply both sides by 200. Gone, gone. So in our calculator, OPP is equal to 200 multiplied by tan of 8 degrees in brackets. So we're going to put that into our calculator. Make sure you're always in degree mode for all these questions that we're doing for this unit. 200 tan of 8. 200 multiplied by tan of 8 in brackets. We get 28.1. 28.1. Watch for the rounding. Make sure that you're rounding correctly. So it says 28.1. Now, the question does say the rounding has to be how high is the tower to the nearest meter? When they say nearest meter, nearest centimeter, this means whole number, no decimal values, no decimals. So when we have 28.1, that rounds to 28 meters. So the tower, therefore, the tower is 28 meters tall. Tall or high. Okay, so that's rounded to the nearest meter. We have everything properly done, labeled. We showed all our work, so that's our final answer. Okay, so watch your rounding, guys. Very important to watch your rounding and make sure that you show your steps. Draw a right triangle and label the vertices. They say label, pick an angle. So we have A, B, and C, for example. Let's say we're looking from angle B. Remember that one side is always your hypotenuse from your angle that you're looking from, and then we have our adjacent. So that would change if we are looking from A versus A, right? So if we were looking at A, this would be called our adjacent right here. So just be careful that if you're looking from an angle, you want to kind of make a marker on it so that you label it correctly. And then this would be our opposites. So we're looking from angle B in this case. And then we would label our sides. Remember, adjacent, opposite, hypotenuse, label always first before you try to solve a problem. Then we want to find angle B in this one. Find angle B. So when we have our angle B, this is our hypotenuse. Then that means that this has to be our adjacent because that's the other one coming out of B right here. And then this has to be our opposite side. So tan of angle B is equal to opposite over adjacent. TOA. T-O-A. Tan of B we don't know, but we do know that our opposite side is 5.5 and our adjacent side is 4.2. So we need to find B by itself. This is kind of a reminder of our first lesson. So in this case, when we want to find an angle, we always have to use tan inverse. That's that tan -1 in our calculator. If we don't use that button, we're not going to get the right answer. So in order to get B to that tan or that B by itself, we have to bring tan to the other side, which becomes just tan inverse in brackets of the ratio that we started with. 5.5 divided by 4.2. So we need to put this exactly how you see in your calculator, tan inverse 5.5 divided by 4.2. So you're going to go shift or second tan, which gives you that tan with a little -1. And then 5.5 divided by, I think it was like 4.2. Yeah, 4.2. Close your bracket. So you want a calculator that can put brackets in correctly. This will make your life so much easier for this unit if you can do that. Now it'll be 52.6 degrees. So whenever you do that tan inverse, you're getting the angle, which has to be written with degree symbol. 52.6 degrees. Let me just check. 52.6, yeah. Okay, so make sure that you have and include that little degree symbol, as you guys can see. So whenever you have tan inverse, you just found the degree, which is the angle between A and H. So that's 52.6 degrees. Okay. And now you want to look at homework for day 2 and practice like 1 or 2 examples. It's really important to see if you're getting this stuff, if you know how to find a missing angle. So this is our day 2 homework on page 82 to 83. These are the questions assigned. So I would just try 1 or 2 questions from there just to make sure that you can do the one on your own and that you're confident with this kind of idea. Okay, so that's it for our day 2 lesson.